Hello everyone and welcome to Network Playroom. So it's been quiet for a while, but now I'm back. So I took a break after Christmas and then started a house project, which has been taking most of my time, with work of course. So I've been away for nearly 2 months. And I'll be moving soon, so expect to see irregular uploads for the time being. But now we're going to pick up where we left off before the Christmas calendar series. So I chose kind of random topics for the Christmas calendar, but before then we were talking about OSPF, and I have at least a couple of more topics I want to cover before we move on to other things. So in this video we're going to talk about OSPF authentication, as you can see from the title of the video. So let me open up the first slide. Now, the use case of authentication is pretty self-explanatory, and it is used to securely exchange routing information. Or in other words, it is used to prevent unauthorized or invalid routing updates in your network. Now, OSPF supports 3 types of authentication. So OSPF authentication can either be null, clear text authentication, or cryptographic authentication. Now, there are essentially 2 ways to configure authentication, at the area level or at the interface level, but in both cases, the password must still be individually configured between the neighbors on the interface. Now, if the authentication type is configured at both area and interface levels, the interface level configuration overrides the area level configuration. So let's say, for example, you had clear text authentication configured at the area level and MD5 authentication configured at the interface level, then the MD5 authentication would override the clear text authentication in this case. Now, the authentication method null means that no authentication is used for OSPF, and it is actually the default method. So there is no password configured between OSPF neighbors by default. And this is OSPF authentication type 0. And there's really nothing more to discuss about it, as in this case, a password is not exchanged between the neighbors. So let's move on to the next authentication method, which is type 1 or clear text authentication, also referred to as simple authentication. And that's the next slide. Now, with simple authentication, the password goes in clear text over the network. And this is, of course, not secure. You could easily capture the password from the packet exchange with a packet analyzer. And in fact, let's look at a packet capture right now. And this is again from packetlife.net. So if we open up this OSPF packet, you can clearly see here that the authentication type is 1, which is simple authentication or clear text authentication. And here in the authentication data field, you can see the password in clear text, and it is Cisco. So, as you can very well see, this is not a very secure method to configure OSPF authentication. But nevertheless, I've also included a configuration example in the slide. Now, I mentioned that the authentication can be configured at the area and the interface levels. And here you can see both, and the interface level command is in brackets because it is not needed for the configuration to work. I just wanted to show you that that's another way of configuring the authentication. Now, let's move on to the next authentication type, which is type 2 or MD5 authentication. Now, with MD5 authentication, the password does not actually pass over the network. What is sent is a hash, which is checked by the receiver. Now, I won't go into the details of how the MD5 algorithm actually works too much, but in short, for each OSPF protocol packet, the key is used to generate or verify a message digest that is appended to the end of the OSPF packet. And the message digest is a one-way function of the OSPF protocol packet and the secret key. So basically, if both routers have the same information, you should be able to produce the same hash, which would guarantee the integrity of the message content. Now, for successful MD5 authentication, the authentication type, the password, and the key ID must match. But one thing to note here is that MD5 is not actually a very secure hash according to modern standards, because the security of the MD5 hash function is severely compromised and various attacks against the algorithm exist. Now, SHA provides better security, which we'll look at after this one. Now, here's also a configuration example for MD5 authentication, and you can see the configuration is very similar to clear text authentication. And again, the interface level command is in brackets. So as you can see here, you could enable the message digest authentication for the area, which is the first two lines or the first two commands in the example. So that goes under the OSPF process, and then there's the interface level configuration. And pay attention to how you configure the OSPF key for these different authentication types. Because a common mistake is to, let's say, enable MD5 authentication, but then when you configure the password, you use the command for clear text authentication. Now, in that case, OSPF authentication would fail. So that's just something to keep in mind when you configure OSPF authentication. Now, the final authentication type is SHA Authentication, which is also type 2. Now let's look at this next slide. So originally, OSPF only supported MD5 authentication, but RFC 5709 allows OSPF version 2 to use SHA algorithms for cryptographic authentication. And with the addition of SHA to the type 2 authentication, this is now called cryptographic authentication for both MD5 and SHA. Now, one important thing to note is that so far, iOS does not allow you to enable SHA authentication at the area level, only at the interface level. So to configure SHA authentication, you first need to define the key ID and the key string by using a keychain, and then apply the keychain at the interface. And notice that the SHA algorithm is also configured under the key. So this configuration is slightly different from the other two methods that we just looked at. But that's it for this video. Thank you again for watching. I hope you got some nice information about OSPF authentication, and maybe in the next video I'll do a lab demonstration about how to configure these different authentication types. So I'll see you in the next video.